Hey, what's going on everybody? It's Caleb. In this lesson, we're going to talk about the HTTP status codes that you need to know when you're building an API. Now, before we get started, I will tell you that you can get the playlist link down below so you can watch all of my backend engineering videos. That'll get you started with an intro to APIs lesson. And the second thing you need to know is that I have the notes for this lesson and all the other lessons. You can get that as well in the link below. So that'd be great if you want to follow along with some code examples as well as a ton of additional resources and links. So would really recommend that to get you the most success possible here. So we've already talked about APIs. It's basically a way to make a request to a backend, and then the backend will give back a response. And this will include a code such as 200, and these will also have some message associated with it, such as OK. So these codes, they have some implied meaning, but you, as the backend developer, usually decide what code to send to the client. So let's say the client makes a request for some data. That hits the server. The server then checks the database, and the database does not find the data. Whatever they're looking for is not there. So the server can then respond to the client with a 404, not found. But you can control that. You can return whatever you want. There are just conventions and approaches that if you follow these approaches, you will create an API that people already know how to use. Additionally, you can follow a spec or a specification, and this will allow for very easy consumption of your API. So the most common example of this would be an OpenAPI spec. And basically, if you want to use one of these specs, you just describe the behavior of your API, what data is expected, what kind of responses might be given back, and you put all of that into a spec file, which can then be read by other software. So we'll definitely get into this idea in more detail, but this is a concept video, so we're not going to build an OpenAPI compatible API in this lesson, but we'll probably do that in upcoming lessons. So again, check out the playlist link down below. So if you're watching this video, you may already understand the basics of APIs, but you want to know the proper way to build an API. Maybe you can build an API, but you want to know the proper conventions, the proper structures, the way you return data, what status codes to use. That's what we're going to cover in this lesson. So before we get into the status codes, we're going to talk about the body structure. So with a request and a response, you can include a body, and I want to talk about the conventions for returning data from the server. We can do one of three things. We can return an array of data, we can return an object, or we can return the data as an attribute of another object. So we would be returning data as a nested object. So these are three different approaches, and not all of these are correct. So while it's technically possible to just return an array directly from an API, it's not considered best practice. So for example, let's say we had users on our app and they were able to configure their profile settings. And one of the things on here was notification settings. And let's say they could get notifications for marketing information. They could get notifications from any replies to their comments, and they could get notifications for security issues with their account. So these might be in an array where we have marketing, replies, and security. So if we wanted to get the person's notification settings, or the same idea if we wanted to update the user's notification settings, the method and the path would look something like this. We could use a get for retrieving this information, or we could use a patch for updating this information. And then we would have /users, / the ID of the user, / notifications. Or you could have a more general /settings. But let's just say we're working with notifications directly, and we want to get this data for a particular user. So let's say user 123. What does the response body look like? Well, it's considered bad practice to just return an array. So the proper way to do this would actually be to encapsulate that array in an attribute of an object. So that might look like this. We have a curly brace, and then an attribute, notifications, and then the value of that attribute is the array. And then we can close the curly brace. Same idea when we send data to the server. If we were to use a patch, we would nest that array in some attribute. I think that's considered best practice. So you always want to be working with the first level being an object. Inside of that object, you can do pretty much whatever you want. Let's go through another example. Let's say you wanted to get all of the users. Well, users is going to naturally give us an array, and this would be an array of objects. So within the square brackets, you would have multiple objects. So it looks something like this, where each one of these is a user. However, same idea here. I don't think it's ideal to return an array back to the client. So instead, we would nest this in a bigger object. So it looks something like this. Users, square bracket, and then that data. So this is the proper response. Now, a scenario where this is a little less clear is if we're working with an endpoint that doesn't directly give us an array. What if we want to say, get users and pass in a specific user, say ID 321. Well, this is going to get us a single user, so the response type is an object. We can give a quick example here, such as name being Caleb. So here's where you have basically one of two options. We can return an object, or we can return data as a nested object. So you could basically just return this, and that would work fine. That's pretty common, but it's probably not as ideal as still returning the object as a nested attribute in a larger object. Just like we did with the array, it's just now a single user instead of multiple users. So we would have user, and the value for this would then be that object. So it'll look something like this. So that closes this inner object, and then this outer curly brace closes the outer object. So you can see that this structure and this structure is consistent. We basically have an attribute describing what the data is, and then we have the data where that data is either an array or an object. This is pretty much what I would always do. So just nest it in some attribute and you can describe what the data is, such as saying users or user. So the conclusion from this is even if you're working with an endpoint that gives us just a single object, we still nest it inside of a larger object. And there's one other major benefit to this, other than just being consistent, and that is it gives us the ability to add in additional information into this outer object without affecting the inner object. So you can see we have this inner object here, and I guess we'll include the attribute name. But for this outer object, we can put in extra information to describe the request, pass in status information, continuation tokens, or whatever it may be. It basically gives us room to provide additional information to the client without impacting the actual data they care about. So here's what that may look like. We can have a large outer object. The thing we're giving back to the client is a user. This contains an object with some attributes such as name, that has a value Caleb, and then we'll close that object. You can additionally put in different attributes here and close the object. We're just going to have one attribute now for simplicity. But this outer object, we're going to keep that open and we're going to then close it down here, which gives us room to add in additional attributes. So we could have a meta attribute for any kind of metadata about the request. I'll just draw that as an empty object. We could have an API version, and that could just be a number. Sometimes the response is embedded in the body, even though it's a little bit redundant with the HTTP status code in the actual response, but that is possible to see. So we'll say response 200. Or if we're working with a list of users, maybe we have to do pagination and that information could be included here as well. So we may have a continuation token, and the client can then access this attribute to know how to make another request. So I haven't really talked about paging yet. That's not the important part here. The important part is that we can add in a bunch of additional information if we need because of the way we structured the response. So this is the structure I'm going to follow. A very easy way to structure this in the code would be to create some variables such as data. And here you would make a database call. I'm just making this up, but it might be something like users.get. And then when you return a response, you can just take this variable, regardless of what it is, whether it's an object or an array, and provide that inside a dictionary, like so. So you'll see this structure quite a bit, where in our code we're working with an array or a single object, but then when we actually provide the response, we just embed it in a dictionary with another attribute. But again, we could then add anything inside of here. Besides the user's attribute, we could add any of these things. So hopefully that's helpful in understanding the proper structure for the response. Cool, so we got that out of the way. Now we can take a closer look at status codes. So off the top of my head, the ones you should know immediately are 200, 201, 204, 301, and 302, 400, 403, 404, and 500. So if you know all of these, you'll be pretty good. And each one of these will also have a small description attached to it. So for example, 404, not found. I'm not going to necessarily write that out every single time or say it out loud every single time. So just know that each one of these will have some message with it. So let's go through each one of these. 200 is okay. That means everything worked as expected. You'll likely get some data back. 201 created usually means you're creating some new resource and it was successful. 204, no content. This basically means it was a success, but the server has nothing to give back to you. 301 and 302, these are two types of redirects, a permanent redirect and a temporary redirect. So this is 301 moved permanently, and then 302 found. 400 bad request. This implies an issue with what you're sending from the client to the server. So maybe that's an issue with the way you structured the body and you need to fix that. 404 not found means the path you're giving doesn't exist. And then lastly, 500 internal server error. This means something went wrong on the server side. So this is a client error, something's wrong with the request. This is a server error, maybe there was an error with the database. So your job as the person building the API is to use the proper status codes to describe what's happening. To get to the solution to this rather quickly, there's basically 5 different request categories and the different responses for them. So we have a get for many elements, a get for a single element, a post, a put or patch, and a delete. Now there are more method types. These are the main ones you should be familiar with starting out. And if you got all this down, the concepts are there and you can pick up all the others quite easily. So when you're getting many, that would be something like /users. And things work, you will either get some data or you'll get an empty array. So this is going to give 200 and return an array. And keeping in mind, that'll be an attribute inside of the response object. But it'll either be an empty array or an array with data. You're not just going to give back nothing. Now, if you're getting a single resource, that would be something like users ID 123. This is going to give an object. So you'll get 200 and an object. However, this could also give a 404 if that object is not found. So that is an important thing to understand here. If you're getting many and nothing is retrieved, for example, you want to get all of the comments on a video, but that video has 0 comments, you're going to get an empty array. However, if you're getting a single element and that element does not exist, you're going to get a 404. You're not going to return an empty object. So we could potentially get back a 404 if we're getting a single element. It'd be like if you put an ID here that wasn't in the database. Now for post, you will usually see 200 or 201. So usually 201 is used for creating new data. And then often this will return the ID of the newly created thing or the new object entirely. This can also give back a 400 if you give bad data to the request. So if the data you're trying to create is invalid, then you can get a 400. Or if that insert is not working properly, you might get a 500 for the server error. Now, put or patch, you will often get a 200 or a 204, which basically says it works, but the server doesn't give back any data. If it's a 200, you will often get the updated object back. Possible issues, we can now get a 404 if the resource we're trying to update doesn't exist. So for example, if we were trying to update users /123, but 123 didn't exist, we could get a 404. But we can also get a 400 for bad data or a 500 for an issue on the server. And then lastly, delete, I'll usually do a 204, but you may also see a 200 with the response being the number of affected rows or some other variations. This isn't necessarily the only way to do it. This here is not the spec. The spec is adhering to a proper HTTP protocol, but you can choose what can possibly happen, and this is what's going to show up in your documentation. So I'm just showing some common things you'll likely see. So if you're like, oh, I don't know what status code to use for a post or a delete, here's your answer. Now, a delete could also give a 404 if we're trying to delete something that doesn't exist, or a 500. It's probably not going to give a 400 because that would imply bad data from the user, but you're not really providing data to the backend for a delete beyond just the ID of the thing you wanted to delete. So usually you're going to get a 404 or a 500. And then we're not really worrying about 301s and 302s, but those are good to know about. And then 403 here, we didn't talk about this because we're not really concerned about authorization or authentication here. So we're going to talk about that, but you can think of this separately from our core functionality. So the client can use these status codes to adjust its behavior. So for example, if we make a request to post/comments, what were the potential returns for this? If it was a success, we'll get a 200 or a 201. If there's something wrong with our data, we could get a 400. If there's something wrong with the server, with the insert, or something along those lines, we could get a 500. Additionally, to post a comment, you might need to be logged in, probably. So we can have another option here with a 401. So we basically have 4 possible paths we have to consider on the client. If it's a 200, we could add the comment to the feed, so it visually looks like our comment was posted. If it's a 400, we might say, yo, try again. And maybe we could figure out a little bit more detail why it's a 400. So if you have some backend validation library, it will usually give some more specific error that you can send back in the response. So it might say something like, oh, the body is required, or the message is too long, or whatever it might be. So you can show that error. So show error, and then prompt the user to try again. You don't just try again without any changes because that client error isn't going to have been fixed automatically. That might be different for a server error. Maybe something went wrong and we just want to retry. But basically with a server error, we would just say a general error message. We usually don't want to give too much information about issues from the server, so we keep it pretty general to the client. If it's a 401, we can redirect to the login page. So you can see how these status codes can be very handy because it allows us to build a client that can respond smartly to whatever happens from the server. Next up, I want to talk about a concept called middleware. And this can be very handy when we are building out responses, and often middleware steps can return different status codes. So far, we have been taking requests and coming up with different responses. But this processing is just one piece in a much larger request cycle. So I'm just going to draw this as a box. But what it might really look like is you receive a request from the client on the server, and then it goes through some steps. So for example, it might go through an auth middleware, which is a really common structure. And then before we give the response back to the end user, we might have some formatting or some internationalization. So these things affect on the after processing of the request, and then we can send it to the client. So basically things can happen before the request and after the request that can modify the request or modify the response. So earlier when we mentioned the most common methods and the common status codes, I was kind of like, hey, you can worry about auth separately. That's because you could have an auth middleware, and this verifies the user. So it checks for authentication, authorization. So very similar ideas, slightly different. Authentication is basically saying, hey, I am who I say I am. I can prove that to you. Here's my username and password. Whereas authorization deals with, do I have access to what I'm trying to access? I might be able to log in, but do I have the permissions to do whatever I'm trying to do? So two slightly different ideas. And it's even super confusing because the 401 status code generally means the person needs to log in. They're unauthenticated, but the message with it is unauthorized. So don't let that trick you. And then there's a 403, forbidden, which is really the unauthorized. So this is unauthenticated. Can't even fit that in there. And then this is unauthorized. So you can almost think of these as backwards. So we'll get a 401 when the user needs to log in, and then a 403 if they're trying to do something that they're not supposed to be doing. So all of these capabilities can be encapsulated in a separate function as part of the middleware pipeline. So each one of these steps would be a step in that pipeline. And the request goes through this linearly, one at a time, with each step potentially modifying or adding to or changing the request that passes through this pipeline until it ultimately gets back to the client. So this doesn't change the end output for the user. It just changes the way we structure our application and think about requests. So this is more a code organization and scalability of our code idea. The end user doesn't see or know anything about this. We may also have things like validation. And this could potentially return 400s. So then we wouldn't even have to worry about 400s in the request, in the section where we're processing the request, because if they make it through the validation and they didn't get a 400, then we know the content is valid, and then we can process it. So this allows our core processing logic to be very thin and single focused, basically. So it's a very nice way to organize and structure our code, and then we don't have to repeat logic in every single function. Very, very important. Last thing is API documentation and specs. So it's often the case, whatever library or language you're using, we'll have some way to work with or document your API. And this might be some specific internal tool for that library, or it might use external things like creating an OpenAPI spec file. So your library might be able to generate a YML or .json file, and this can then be read by other tools to generate docs and interfaces to work with the API. This is huge. Anytime you can generate stuff, you should probably do it. So an example of another tool here would be Swagger. And this is closely associated with OpenAPI, but it's not the same thing. Think of Swagger as the tool. OpenAPI is the actual spec, but Swagger can read OpenAPI documents and give us a very easy to use UI to interact with that API. So then if you're working in a team or you need to share this API with other people, you don't have to tell them what every single possible thing is. They can just look at the UI and see the possible inputs and potential errors or output concerns they need to consider. So this makes building the actual interaction between the backend and the front end 1,000 times easier. So check with whatever library you're working with if they have a way to generate the OpenAPI spec, or there's likely another library for the language that you can download to do that. If not, you can create these files yourself manually. It's not like impossible. So you can do that as well if you're working with a perhaps newer language that doesn't have as many good libraries out there. There are also other options for documentation. For example, there's Postman. And this is generally considered a tool to interact with an API, to test it, to build an API. You can think of it as an alternative to a web browser, but with stronger support for the different methods and the different variations you'll need for testing APIs. But you have the ability in Postman to create collections. And collections can act as a documentation for your API, basically showing what endpoints, what they expect, and so forth. And Postman has ways to generate docs from these collections. So in the notes, I'll leave additional information if this is something you're interested in. Last couple of things I want to mention, just as a bonus here, is you can also utilize AI, which should be able to document APIs on the fly. So that's another alternative, is to actually document when you need the API using AI. Or another thing I wanted to mention is you can go through the effort to build a docs website, such as Docusaurus or some other markdown renderer. This is pretty important, or more common for public APIs. So that's something you might want to look into as well. That's all I have in this lesson. Hopefully it was a good introduction to the different codes you might run into. There are a ton, but the ones we covered are the most important to get started. And as we build out APIs here soon, we will see these again. Thank you so much for watching, and stay tuned for the upcoming lessons. Be sure to check out the playlist link. That's where I'll put everything, and I'll see you in the next one. Peace out.